This video will go over incremental sampling methodology, or ISM, and recommended best practices. This includes best practices for entering locations, sampling information, laboratory data, and for validating ISM data in FUDSChem. The Interstate Technology and Regulatory Council, ITRC, Technical Guidance Incremental Sampling Methodology, ISM, update should be referenced for the application of ISM. The video description lists timestamps to help you navigate to the portion that you need. Introduction. Prior to sampling, decision units, or DUs, will be established. They are site-specific and represent the smallest volume of soil for which a decision is to be made. The decision unit may be subdivided into sampling units, or SUs. A decision unit may consist of one or more sampling units. Sampling units represent the volume of soil from which increments are collected to determine an estimated mean concentration of the analytes of interest. An increment is a volume of soil collected from a single grid within a decision unit or sampling unit. Combining multiple increments forms the incremental sample. The incremental sample will be processed and analyzed to estimate the mean concentration in the decision unit or sampling unit. One combined incremental sample represents one field sample. Once the incremental sample and replicate field samples are received by the laboratory, the samples will undergo project-specific sample processing and subsampling. A subsample is a small portion of material selected from the field sample by the laboratory for analysis. 3 or more subsamples may be taken from a single field sample as subsample replicates. The subsampling replicate represents the laboratory replicate in FUDSChem. For ISM application, the field samples and laboratory subsamples should never be referred to as a duplicate or triplicate, but as replicates. Replicate samples are independently collected incremental samples. Locations. In FUDSChem, sampling units will be entered as locations under Tools, Data Submission. We will go over only the parts of this interface that have specific requirements for ISM sampling. For information on the other parts of the interface, please refer to our Loading Locations to FUDSChem tutorial videos, linked in the description. Data is loaded into FUDSChem on the sampling unit level. A specific decision unit entry is not required to be entered into FUDSChem. Let's talk about some best practices for naming conventions of sampling units in FUDSChem. Following these best practices can help to clarify the relationship between decision units and sampling units. While naming conventions are determined on a project-specific basis, in general, the sampling unit should include reference to the decision unit. The decision unit should consist of the site ID followed by the DU indicator. Sampling unit location IDs should start with a 3 or 4 character site identifier followed by a hyphen, then their parent DU identifier followed by a hyphen, then SU and 2-digit identifying number with leading zeros. For example, let's say we're entering sampling unit number 4 for decision unit number 1 at our Camp Richards base. We would enter CRB for Camp Richards base, followed by a hyphen, then DU01 for decision unit 1, followed by a hyphen, then SU04 for sampling unit 4. Note that the location ID field only accepts up to 15 characters, so we could drop leading zeros or hyphens if needed. If only one sampling unit will be defined for a decision unit, it is acceptable to leave off the SU designator, instead of adding SU01 to the end. Regardless of how the location is named, it will be considered an SU, and therefore we'll choose a location type of sampling unit. We'll enter the coordinates for the sampling unit centroid as our northing and easting. As a best practice, KML formatted polygons should be used to define the shape of each sampling unit. The location definition interface includes an option to import a KML file for each location. If you are loading a flat file instead of using the interface, a set of clearly labeled KML files can be sent to your Synectics point of contact for import. For more information on creating KML files, please refer to our KML Files and FUDSChem video, linked in the description. Entering the remaining information would follow the same process that is outlined in our Loading Locations to FUDSChem tutorial videos, linked in the description. Samples. FUDSChem's tools can be used to plan your ISM sampling event under Tools, Data, Event Management. We will go over only the parts of this interface that have specific requirements for ISM sampling. For details on entering event management information, please refer to our Event Management tutorial videos, linked in the description. After filling out the Assign Locations tab and Assign Methods tab, navigate to the Assign Field Samples tab to input your sample IDs. As a best practice, we recommend naming samples according to the naming conventions in the FUDSChem user guide. Start with a location ID. If replicate samples are being taken, add R followed by a number to designate the replicate number. Next will be an underscore, then a unique timeframe indicator such as the year and quarter or year and month. Typically for the DoD, at least 3 sample replicates are collected for each sampling unit. So for this example, we will copy 3 lines for our sampling unit. We will name the field samples using the location ID followed by a replicate number, followed by time frame. The sample type for all field sample replicates will be FR for field replicate. The sample numbers will be set to 1, 2, and 3. Note that laboratory replicates will not be included in event management. If our location did not include replicate samples, it would be treated a little differently. Its single sample ID would not include the replicate number. It would just be the location ID followed by a time frame indicator. The sample type would be normal. For more guidance on how to fill out the rest of the event management information, please refer to our Event Management tutorial videos. For guidance on entering chain of custody information after sampling has been completed, please refer to our Field Sampling ChemField Entry tutorial video. These videos are linked in the description. Lab. The lab will have some special considerations when entering ISM data into FUDSChem, specifically around which valid values to use. We will review the valid value report by going to Reports, Data Validation and Submission Reports, Valid Value Lists. We'll choose SED 5.2 2A5 as the data table. For the data types, we will pick Analysis Type, Handling Type, QC Type, and Result Basis. Click View Report. Typically, ISM samples will be sent to the lab in replicate. All replicates should be assigned the QC type of field replicate. Laboratory replicates assess the precision of the laboratory sample processing procedure and sample representativeness. The QC type for these additional samples is laboratory replicate. Laboratory replicates can be distinguished by an analysis type of replicate number, where the number is recommended to be 3 or more. If present, the QC type for a grinding blank is grinding blank. Note that the SDG will be used for batching. If drying occurred, for either correction or handling, the result basis should be dry. If correction is applied to the data, a characteristic node should be reported listing the percent solids. If no correction is applied, exclude percent solids and percent moisture from this sample plus method node. Handling nodes should contain a handling batch and handling type information from the valid value list to denote sample processing procedures, such as if puck milling or ball milling were utilized. Depending on the procedure, More information such as amounts should be included. Inclusion of lab method ID and lab method name is preferred. However, the batch and type are the only fields required. Note the lab may optionally include the relative standard deviation as %RSD element in their said file. However, regardless of whether the lab includes the %RSD element, the RSD will be recalculated by FUDSChem. We discuss the report that does the recalculation in the next section. For more information on how to enter said data into FUDSChem, please refer to our laboratory said submission tutorial video, linked in the description. Validation. Once the lab has submitted the data, FUDSChem's built-in automated data review will apply qualifiers automatically. If present, the grinding blank should be evaluated manually. Incremental replicate samples can be reviewed under Reports, Data Validation and Submission Reports, Field Replicates by SDG. This report calculates the relative standard deviation of the 3 field replicates. Note that the report will only run for datasets of 3 replicates. We can see the report includes the location, analysis, and sample IDs on the left. The analyte and field sample replicate results follow. The RL/LOQ column is populated with the limit for replicate 1. The RSD and RSD criteria are on the right. This report can be used in conjunction with the other validation reports and tools to validate ISM data. When applying qualifiers, note that specific validation reason codes are found under Reports, Data Validation and Submission Reports, Data Qualifier Reason Code Definitions. Codes for field and lab replicate RSD or grinding blank contamination are available. For more information on how to use the validation tools available in FUDSChem, please refer to our validation tutorial videos, linked in the description. Don't forget to subscribe to the FUDSChem YouTube channel for more tutorial videos. All of the tutorials and playlists mentioned during this video are linked in the description below. Lastly, if you have questions or comments, feel free to contact us at fuds.support@synaptics.net. Thank you.